Hello students, this is the question from computer organization. Question is the frequency of different types of instruction executed by a machine is tabulated below. Okay, so for register, the frequency is given as, so this is the frequency chart. Okay, frequency is given as 30%, in percentage it is given. Then for memory immediate it is given as 20. Then for direct memory access it is given as 22. For memory indirect 17, and index 11. Okay, and we have to assume 2 cycles are consumed for an operand. Okay, they have given that two cycles are assumed for the operand, right? And to be read from the memory. If it is reading directly from the memory, then 2 cycles are assumed. Now, 1 cycle assumed for index and arithmetic computations, right? So if it is doing an index, it is accessing mode is from index thing, then it will be only 1 cycle, and 0 cycle if the operands are available in registers or within the instruction itself. Means if it is available in register or it is in the immediate accessing mode, then the cycle will be 0. So we have to calculate the average fetch cycle. So what do you mean by the average fetch cycle? Average fetch cycle. Average fetch cycle is a process by which it is a process by which computer retrieves a program instruction from its memory. Okay, and since memory is divided into these many parts, so these many parts are divided, right? So the fetch cycle will be the summation of all these things. Whatever, how we are going to access from these types of memory, for that will be the average fetch cycle. Okay, so the cycle required for register mode. Okay, then cycle for immediate, then cycle for direct, and then cycle for indirect, then cycle for index. I need to tell you one thing at this point. This is there is given memory indirect. Okay, so memory indirect, what is memory indirect? Okay, so it is address calculated using the node with the actual address location, okay, which contains the actual effective address. Okay, so the address calculated using some node is in fact the address of a location which contains the actual effective address. Means it will contain only direct addresses. Okay, it is the direct addresses will be the memory indirect. Okay, means for going and coming twice it will be calculated effective addresses. And if you go for index, it will be the summation of index value and the direct, or whatever the address location given for the direct, that will be added to this one also. Okay, so in index the cycle will be containing this value also, and in the cycle for memory indirect, twice the cycle will be taken for direct. Okay, so I can break this statement as, it will be cycle register, then it will be cycle immediate plus cycle direct. So this will be broken as, this indirect will be broken as cycle. So 2 cycle will be considered for this one, and then cycle index will be cycle index plus cycle direct. Okay, So now, what is the per frequency? It is 0.30, right? So it will be 0.30 into what is the number of cycles for, if it is in the register, it will be 0, right? So it will be 0. Then cycle for, if it is within the instruction itself, then it is also 0. So frequency is 0.20 into 0 plus, for direct it is 22, right? So it will be 0.22 into 2, because two cycles are required for if an operand to be read from the memory, right? So then it will be 0.17 into 2 plus 2, right? Then it will be 0.11 into 1 plus 2. So this value will become 0 plus 0 plus 0.44 plus 0.17 into 4 plus 0.11 to 3 will be 0.44 plus 0.68, 0.33. So it will be 1.45, right? So the answer is A. Okay, thank you.